around 33 papers in various journals. He has edited two special issues of International Journal of Globalization and Small Business. He has currently reviewing three papers of international journals. He has been awarded sponsored research project by AICTE New Delhi under Career Award for Young Teachers Scheme. He has been awarded a sponsored research project by UGC. He has participated in the e-learning training program on the Toyota production system organized by Asian Productivity Organization, Japan, and National Productivity Council, New Delhi. So, a very heartily welcome to Sharma sir. Sir, you may please can start your lecture, sir. I hand over the mic to you. And I am very sorry to all the participants for the delay. And to you also, sir. सर आपकी आवाज नहीं आ रही सर.
Hold on. Hello, am I audible?
Audible.
ये स्क्रीन दिख रहा है आपको पीपीटी?
Yes sir, it is visible.
Yes, visible.
Yes.
मिलिंद सर आपकी आवाज भी एकदम बढ़िया आ रही है और आपकी स्क्रीन बढ़िया दिख रही है. And most welcome to the program. Thank you for accepting.
Thank you very much. My pleasure. So today I have been asked to deliver a talk on multi-criteria decision making. So I have decided to give a broader overview what the MCDM is all about, what are the popular techniques and their application area. So before I navigate to MCDM directly, let me come to the general term, what is decision making? Generally, decision making is a vast area of study, involves a lot of factors. I mean, we in our day-to-day life takes many decisions. In some of the decision we are in dilemma. There are certain decisions which we can take very easily. We have different options. We have the clarity. We have the vision to take the decisions. So decision making is an important part of our day-to-day life.
मिलिंद सर एक आपका जो आपका स्लाइड शो कर दीजिए. अभी स्लाइड से हो, स्लाइड शो नहीं हुआ है.
एक सेकंड. अभी ठीक है? Is it okay now?
Yes, it is okay now. It is okay.
Yes, sir.
Yes sir, it is okay.
So the decision making is simply interpreted as the process of selection of various options or the alternatives. So like in our day-to-day life, if we make many decisions like which school to take, which clothes to use, which food to eat, which car to buy, and so on. So decision making, when taking a decision, there may be many alternatives. Sometimes they are finite in number, sometimes they are infinite in number. So there may be many alternatives in some situations. There is also some possibility for not having a suitable choice of different criteria in certain situations. So multiple criteria decision making is basically an approach designed for the evaluation of problems with a finite or an infinite number of choices. So multi-criteria decision, as it is evident from the term itself, when you have more than one criteria at your disposal and you have to take a decision to arrive at a conclusion. So what is the process of decision making? If you look at this slide clearly reveals that decision making is a step-by-step process where initially we identify the goals, aims, objective of the problem, why we are taking a decision. In simple language, it is a problem statement. When we clearly identify the objective or goal, then the next step is selection of criteria. What are the different criteria? Then selection of the weighing methods. If you have different criteria, then sometimes you have to weigh the option. So weighing option, which method we have to choose, that is the next step. Then aggregation, of course, and last but not the least, decision based on the aggregated results. Coming back to the MCDM. Generally, MCDM is classified as MODM, multi-objective decision making, MADM, multi-attribute decision making, and sometimes combination of both MODM and MADM. Popular techniques AHP, ANP, Lactae, Vicor, Promethe, Topses, Damtel fall under the category of MODM, multi-objective decision making. Whereas linear programming, goal programming, popular operation research, mathematical modeling techniques fall under this category of multi-attribute decision making. However, there are certain instances when we use combination of these. This slide throws light on multi-criteria decision models. Generally, two types of MCDM models are reported. One is compensated decision making and other is outranking decision making. In compensated decision making, we have certain alternatives which are negatively attributed to the goals. So basically, we try to compensate the impact of negatively attributed criteria by compensating them on the other criteria which are positively attributed to the goal. The examples are AHP, MAUT, fuzzy, MCDM. They fall under this category of compensatory decision making. Whereas Electri and Promethe are the popular outranking decision making models. Now, selection of models and techniques. How one has to choose the different techniques or models, MCDM models. So generally, they are based on following criteria: internal consistency and logical soundness, transparency, ease of use, data required are consistent with the importance of the issue being considered, realistic time and manpower resource requirement for the analytical process, ability to provide an audit trail, and the software availability where needed. So generally, these are not thumb rule. Generally, these are the selection criteria when we have to zero in on a particular MCDM model or techniques. So this slide gives the different techniques, their advantages, limitations, and the area of application. So multi-attribute utility theory, very popular MCDM techniques. Advantages are it takes uncertainty into account and can incorporate preferences easily. However, the limitations are it needs a lot of input. Preferences need to be precise. Sometimes inaccurate preferences may lead to a poor decision making at later stage, which could prove to be a very costly affair for company. Applications are immense in economics, finance, actuarial, water management, energy system. So there are many applications which support the multi-attribute utility theory. And in literature also, we can say that MAUT is quite popular even today. Another popular technique is AHP, analytic hierarchy process, suggested by the Thomas Sati. Its advantages are immense, easy to use, scalable, hierarchy structure can easily adjust to fit many size problems, and of course, it is not data intensive. So easy to use, make it very popular among managers, even in industry, particularly in manufacturing industry. AHP is is being popularly used because it is easy to explain, easy to use, easy to understand, and the inferences may be drawn easily. But it has got its own disadvantages, such as that interdependence between criteria and alternatives can lead to inconsistencies between judgmental and ranking criteria, rank reversal. So it's very important that before the alternatives or the criteria are ranked, pairwise compare, there should be a unambiguous understanding of interdependence, interrelationship among different criteria and alternatives before an opinion is sought. So generally, it is suggested that when the hierarchy is established and for feedback, taking the feedback from the respondents, we explain the hierarchy, criteria, and alternatives and their interdependence, interrelationship clearly to the respondents in order to seek proper feedbacks and having consistent results in our analysis. And AHP has got wider application even in literature even today. So it was launched in early 80s. Even today, there are many analyses we can see reported in literature. Another popular model is CBR, case-based reasoning techniques. Its advantage, like AHP, it is not quite data intensive, requires little maintenance, can improve over time, can adapt to changes in environment. So its ability, its rather flexibility to change according to the environment, uh, put an edge over other techniques. However, when we talk about disadvantages, it is sensitive to inconsistent data. The same limitation that we have discussed, we have seen in case of AHP that remains still valid for CBR. So it is sensitive to inconsistent data. So it is pertinent whosoever is using it that our data are consistent. And of course, to take a call, we require many cases, many examples. Many cases are needed for the CBR. Areas of applications are businesses, vehicle insurance, medicine, engineering, and design. So these are the major application area where we can find the application of CBR. Another technique is a DEA, data enveloped analysis. It is capable of handling multiple inputs and outputs. Efficiency can be analyzed and quantified. It is based on linear programming. We may say that it's an application of LPP, linear popular or mathematical technique, linear programming problems. So generally, scale efficiencies are computed by using this DEA technique. However, it does not deal with imprecise data, assumes that all input and outputs are exactly known. So here we should appreciate that DEA, while offers many advantages, its major disadvantage is that we may say that it is an intelligent technique because it assumes whatever inputs are given to it, they are accurate, they are exact, and so are the outputs. Its area of applications are in economics, medicine, utility, road safety, agriculture, retail, and several other business problems. Moving on to other techniques, the popular is the fuzzy set theory. It's very popular, commonly used, cutting across the several industrial disciplines. Advantages are it allows for imprecise input, takes into account insufficient information. So even if we will have the imprecise inputs, it take care of this imprecision, and it takes even if the information is insufficient, this fuzzy set theory supports the users. However, it is difficult to develop, and sometimes it is observed that it can require numerous simulation before it is being used. Areas of applications are in engineering, economics, environmental, social, medical, and management. So you name any area, you will find its application widely being practiced by managers and several business operators. There's another technique, simple multi-attribute rating techniques, SMART. It's simple, allows for any type of weight assignment techniques. It needs less efforts by decision makers. However, procedures may not be convenient considering the framework. So sometimes it is felt that the framework becomes very complicated. So it becomes difficult for decision makers to understand it. So it is considered that if the framework is clear, unambiguous, then the SMART techniques can give the can support the decision maker. Goal programming is another popular technique which is capable of handling large scale problems, can produce infinite alternatives. So it is also known as multi-objective programming, when we have more than one objective functions and when we can prioritize or by employing a suitable weighing mechanism, we can give some ranking to the different goals. So that kind of situation can be easily handled by goal programming. So goal programming is akin to linear programming only, with the difference that it handles when there are more than one goals. For instance, if there are three goals, three objective function equation, and let us say 10 constraints, by employing any suitable ranking methods, if we prioritize the goal, so the most important goal is to be, the problem is to be solved for the most important goal. The next stage, when we solve it for a second most important goal, then the number of constraints, which was originally 10, now it becomes 11, because the goal programming logic suggests that in order to meet the second most important goal, the first or the most important goal must not be violated. So in that situation, when we solve the goal programming for the second most important goal, so first important goal becomes the constraint. So in that case, we will have the 11 constraints. Similarly, when we try to solve the problem for the third important goal, if there are three goals and this third one is the least prioritized goal, so it is imperative that the first two goals should not be violated. So in that situation, the number of constraints now becomes 12, because 10 are the original constraints and the 2 are the goal constraints. The first goal, which is the most important goal, and the second one is the second most important goal. So goal programming, this is how it handles multi objective function at a time. However, disadvantages are that its ability to weight coefficients typically needs to be used in combination with other MCDM and method to weight the coefficient. So major disadvantage is that we need to have a proper mechanism in place to rank different goals. If the ranking becomes faulty, then we may have results which could give a disaster at later stage. So we need to have a logical weighing coefficients for different objective function while using this technique. And generally, it is seen that it is used in tandem with some other techniques. Like whenever you must have seen, and we may see easily, that analytical hierarchy process is generally used in combination with goal programming and the vice versa. So in many of the papers and the industrial application, we may say that we may see that AHP, PGP kind of a technique, a combination of AHP with goal programming has been used. Many of the transportation problems and the cargo shipment problems, if you see, they are their solution. I mean, the AHP is being used in conjunction with the goal programming and delivers the results in such a manner that the limitation of the AHP is being compensated by the goal programming and the vice versa. So, in combination of some other techniques, makes it a complementary, in the sense that one technique's disadvantages may be compensated by some other techniques. So generally, goal programming is used with some other techniques. Another model MCDM technique is electray. Advantages are it takes uncertainty and vagueness into account. So it is a big advantage. Disadvantages, however, its process and outcome can be difficult to explain in a layman's terms. Unlike goal programming and the AHP, its understanding to a layman is difficult. Outranking causes the strength and weaknesses of the alternatives to not be directly identified. This is another limitation of this technique. However, its area of applications are energy, economics, environmental, water management, and transportation problems. Promethe is another popular technique which is easy to use, does not require assumptions that criteria are proportionate. However, it does not provide clear method by which to assign weight. So this becomes problem with this technique because there is no defined way to allow ranking or allow the weights. It has got wider application in environmental, hydrology, problem management, business, finance, chemistry, logistics, even sustainable manufacturing is the area where this technique is being popularly used. Simple additive weighting, SAW. This technique has got immense advantage as because its ability to compensate among criteria, intuitive to decision makers, calculation is simple, does not require complex computer programs. While discussing while disadvantages, it estimates reveals do not always reflect the real situation. The results obtained may not be logical at times. Topsize technique for order preferences by similarity to ideal solution is another popular technique. It has a simple process, easy to use in program. The number of steps remains the same regardless of the number of attributes. This is very important advantages. The number of steps remains the same, notwithstanding the number of attributes are being used. Its use of Euclidean distance does not consider the correlation of attributes. This is the major problem with this technique, and difficult to weight and keep consistency of judgment. It is very popular technique in SCM, supply chain management, logistic engineering, manufacturing system, businesses and marketing, environmental and human resources, and water resources management. So, in general, we may summarize that the MCDM's applications lie in resource management, energy planning and management, logistics and transportation engineering, information technology and communication, water resource management, risk analysis, structural analysis, city planning. So you name the area, you will find its application being widely used. Now, I'm going to navigate quickly the techniques that we have seen in the form of table to explain what the AHP is all about, different techniques all about. So I will take AHP first, analytical hierarchy process. It was suggested by the Thomas Sati in 1980. It is popular, widely used method in MCDM. Allows the use of qualitative as well as quantitative criteria in evaluation. In this approach, decomposes a problem into distinct hierarchies and evaluates each hierarchy by comparing them in a pairwise manner. So this is one hierarchy where on the topmost is the objective goal, then different criteria, alternatives. In between alternative and criteria, there may be many layers of different sub-criteria. So AHP algorithm is basically composed of two steps: determining the relative weights of decision criteria and to determine the relative rankings. popularly known as priorities of alternatives. So both qualitative and quantitative information can be compared by using informed judgments to derive weights and priorities. So with this small example, suppose we have to take a decision on selection of a particular car or a model. So here objective is selection of a car, whereas criteria are aesthetics, performance, fuel economy, etc. So for illustration purpose, I've taken in this slide only 3 criteria. Criteria may be as many as the situation allows us. And here alternatives, I've taken 4: Honda City, Ford Fiesta, Nissan Sunny, and Hyundai Verna. So objective here is the selection of a car. Criteria are 3: aesthetics, performance, fuel economy, and the alternatives are 4. So here is the hierarchy. Can you see that? So the objective or the goal is selecting a new car. Criteria are aesthetics, performance, and fuel economies, and alternatives are 4. So this is how we draw hierarchy in AHP. Now, pair-wise comparisons are made with grades ranging from 1 to 9. If a attribute A is absolutely more important than B, for instance, and is rated as 9, then B must be absolutely less important than A. So this analogy we use for pair-wise comparison in AHP. So these pairwise comparisons are carried out for all factors to be considered, usually not more than 7, and the matrix is completed in this fashion. So there are 3 criteria: aesthetic, performance, fuel economy. So these 3 criteria are pairwise compared. So if you look at this matrix shown in this slide, you will see that when the performance is compared with aesthetic and the fuel economy, so you may say that the fuel economy found to be more important than the performance, and the vice versa. So this is how the pairwise comparison is made among different criteria, and if sub criteria are there, we may follow the same uh, process, and for alternatives as well. So this is the ranking priorities we do. So we normalize the column entries by dividing each entry by sum of the column and take the overall row average. So this is how the rankings are normalized. So this is what we do in HP. Now the priorities, if you see it, that aesthetics, performance, and the fuel economy, the performance were given the more weightage. Now, similarly, now selecting a new car, now you have the 3 criteria: aesthetic, performance, and fuel economy. And by comparing them, we may say that the fuel economy was found to be least important criteria. Now, these criteria vis-a-vis different alternatives are compared, pairwise compared, like we did in case of alternatives. So this is how the various models, City, Sunny, Fiesta, Verna were compared, and we prioritize their preferences vis-a-vis different criteria, different alternatives. In aesthetics, if we see from the perspective of aesthetic, the Sunny has got more weightage vis-a-vis the Honda City, and so on. So different models were compared under different criteria. And we come to the conclusion that after the normalization of the priority, that which alternative among which criteria is most suitable. So this is how the AHP gives us the result, that if you are to select a new criteria and the aesthetic is the alternative, is the criteria, then which of the models, City, Sunny, Fiesta, Verna, what is according to their importance or prioritization, what are their signal. Similarly, when the performance is the criteria, we may see that Honda City is given preference for its other competitors. Similarly, when the fuel economy is in question, we may say that the Fiesta has got the least importance. So this is how AHP delivers us the results. So this is how priority metrics and the criteria weights are formulated to give the global priority of different alternatives: City, Sunny, Fiesta, and Varna. So from overall perspective, when it combines aesthetic, performance, and fuel economy together, which of the options is the most suitable? So that is again given by this table. So if cost again become one of the decision criteria, though it was not included initially. Initially, aesthetic, performance, and the fuel economy was the only consideration. If cost also becomes one of the considerations, so we can add it as a new criteria. However, inclusion of the criteria at this stage is difficult, but we may add it in this manner by doing the cost benefit analysis, in the sense that the normalized cost is to be multiplied by the different weightings that could give us the cost benefit ratio. So here the advantage the AHP offers, that if at a later stage you are to add some additional criteria which was not there in the picture initially, you can find out the cost benefit ratio and chalk out your strategy in decision making. Another example of supply selection supply selection problem solved with the help of the AHP. Sony sir, are you there?
Yeah, I'm here only.
Sir, if you recall, I just want to mention an incident. This is the same supply selection problem that you evaluated once few years back. So this was
I remember your MTech student. Yeah.
yes, our ME student, PG student. So that is this
I know.
this slides. So this was a case of Mazdi's bench Daimler, which where one project was done by a student of supply selection model. So there the HP was being used. There are different criteria of supply selection like quality, cost, delivery, service, long-term contracts, flexibility, etc. So while using different criteria, the AHP deliver us that under which criteria which supplier gives the optimum results. And when we consider the overall supplier selection model, which of the supplier gives the best results. So AHP in popularly used in supply chain management in this manner as well. So this is just a case of AHP solving the supplier selection problem. So in HP, we have seen the interdependence in hierarchical model. So in a hierarchy, alternative affects the criteria and the criteria affect the alternative. And there was some assumption in HP like criteria do not affect the alternatives, criteria do not depend on each other, and alternatives do not dependent on each other. However, in complex decisions, there may be dependency and feedback. So there, ANP is preferred choice for AHP. So ANP is an analytical network process. Network model improves the priorities derived from judgments and make predictions more accurate. So here you may see that we make a network rather than a hierarchy. So inter criteria or the inter alternative interactions is allowed in the ANP process. And rest are the same as AHP. So it may be acknowledged that the interrelationship among different criteria and the alternatives are possible while using ANP. So this is how we may say that ANP has got an edge over AHP under such circumstances. Fuzzy MCDM is also a popular technique. As we may see that AHP and ANP both uses crisp values of pairwise comparison. But in some of the situation, and rather in today's time, majority of the situation, we may come across where crisp values may not be used for pairwise comparison. So to deal with such kind of uncertainty in decision making, fuzzy approach is found to be more suitable than the AHP or the AN. We all are aware, I mean, linguistic variables are used to pairwise comparison in case of fuzzy MCDM. And further, the linguistic variables are converted into fuzzy sets. Like equally preferred, we will have the 1, 1, 1. For weakly preferred, fairly strongly preferred, very strongly preferred, and absolutely preferred. So we have their corresponding value attached to those linguistic criteria. Calculation of MCDM are done with fuzzy numbers, and then defuzzification can be done to find the crisp result at the end of the day. So at the end of the day, when we take a call, we defuzzify the numbers to get the crisp results in decision. So this is how we may use fuzzy MCDM in our day-to-day. So these are some references I've used to make this presentation. The references cited at number 3 and 4 are the supply selection problem that has been dealt in year 2015-16, where Dr. V.K. Soni evaluated this master level thesis. Later on, with the permission of the manufacturing industry, where we carried out this project at Chennai. These two studies have got published in Journal of Modeling in Management in 2016 and in Benchmark in International Journal in 2015. So these are available on my web page also, where DEA AHP technique has been used, then DEA AHP and fuzzy technique has been used in 2016 paper. So this is what today I have planned for this FDP. I'm sure this presentation would give a kind of sensitization to body researchers that MCDM is a very popular technique, very easy to use techniques, and it has got wider application in research, ranging from different areas and different walk of life. So with that, I would like to finish my presentation.
Milinji, I can see there are a couple of questions asked at chat box. Can you see that?
I will have to find out just. Uh, uh, I can see only this. Just a minute. From Anand Prakash Tiwari, right? The question is
Ravinder Singh also is there.
different MCDM methods yield different results. Kindly explain how to validate which method has given the optimal. Sir, let me tell you that this is a very difficult question to respond, right? In fact, you see, there are no thumb rule as such, right? At times, you have to depend on based on more than one technique to arrive at a conclusion. Now, the question is how to take a call on that which technique would be better in what scenario. I believe this is your question, right? So my answer to it is that you have to look at the what kind of responses you have. If your responses are crisp, clear, unambiguous, without any ambiguity, then I'm afraid that then I'm sure that a simple technique like AHP can give you the results in a very precise manner, which can deliver you the fruitful results. So it all depends on the kind of input, the kind of people you are dealing with, the kind of problem I mean, your ability to explain the problem, to explain the hierarchy, their interrelationship clearly to the respondents. I give you one small example. Suppose you are to rate delivery time over flexibility, right? When you are referring to a flexibility, you need to be very clearly in a explicit manner explain to the respondent that what do you mean by the flexibility, whether it is a delivery flexibility, whether it is a volume flexibility, or some other kind of flexibility. You see, if you do not explain respondent that by asking the flexibility what exactly you are seeking, I'm afraid you may get ambiguous ranking, ambiguous results. So best of the best techniques, I mean, no matter which techniques, everybody is biased towards a particular technique. So in the absence of clear feedbacks, the best of the techniques may not give you the required result. So my answer to this question would be that there's no such thumb rules. You have to look at what kind of responses you have, what kind of what type of understanding has been developed. Uh, Hello. You have to explain what kind of data you have, how crisp or accurate the data are. So these are all dependent on that. So I would say that if you have the accurate results and the people understand your hierarchy interrelationships clearly and they give the right feedback, so AHP can also give you results which can deliver us the optimum result.
Good afternoon, sir.
Yes, sir.
Yeah, shall I speak now, sir?
Yeah,
So,
please go ahead.
I'm
Please
giving
go
you
ahead.
the specific example. My research area is micro machining.
Okay.
What exactly we are doing? We are doing the machining, and then we are getting the experimental value. We are trying to optimize the input parameter. We are trying to find the optimal combination of the input parameter so that we can get the desired result. For example,
Right.
if I have done some experiments in the area of micro EDM, so here the input parameter is the peak current, gap voltage, flushing pressure, and pulse on time. The output parameter is material removal rate, which should be higher. Tool wear rate, that should be the minimum. Maximize the tool wear rate. Minimize the tool wear rate. Then minimizing the geometrical inaccuracy like overcut and taper. So what I did, sir, in the same experimental data value, I used two different types of the technique. For example, the TOPSIS, fuzzy TOPSIS I used, and PCA, principal component analysis I used. And
Okay.
I was surprised, sir, I got the different optimal combination of the process parameters.
Right.
So,
Okay.
yeah, anyhow, since I had to publish the paper, I justified, but I'm still not convinced, sir, how to select the both the methods which I used, both are the statistical methods.
Sir, while using the principal component analysis, PCA technique, you are saying, right?
Yes, sir. Yes, sir.
So you must have used the Varimax rotation.
Which one, sir?
I mean, while doing PCA, principal
Yeah.
component analysis, so
Yes, sir.
Varimax, I mean, rotation you must have used.
No, sir. I calculated the eigenvectors by using the Minitab software.
By using the Minitab software
Yes, sir.
eigenvalue.
Yes, sir.
Okay,
Yes, sir.
okay. So, well, my answer, but I'm sure the results are not diametrically opposite to each other.
No, it is not. But
It is.
some differences are there. But
Mhm.
if but those differences are also considerable.
Okay. Mhm.
For
Mhm.
example, in micro EDM, the process
Mhm.
parameters are in the micron range. For example, if you
Mhm.
are using 1 ampere peak current and 1.5 ampere peak current, that makes a huge difference in the experimental result.
Okay. Okay.
Yes, sir. Yes, sir.
You see, my suggestion to you would be that though we can talk privately also, what influence you to use PCA for this technique? You see, PCA while using Minitab, you suggested that you use the Minitab for PCA, right? So
Yes, sir.
principles component analysis for PCA technique is using the Varimax rotation. Since you are not used the Varimax rotation, I would suggest that you use the Varimax rotation technique for PCA. And I'm sure since you've taken the eigenvalue and all these things.
Yes, sir.
Hello, am I audible?
Yes, sir. Yes, sir. Yes, sir.
So I would suggest that for the same set of results,
Yes, sir.
you use the Varimax rotation technique while using the PCA, and you just share the results. Then I'm sure I may be in the position to tell you something in a better way.
Yeah, I think Milindi ji, can I add something to your address to the query?
Yes, sir. Sure, sir. Sure.
Yeah. Professor, the person who has asked this question, so there are two things. So when you are picking up the technique to bring out the decision, final outcome, you first go into the what kind of data you are going to handle. As a principal component analysis, I don't know, Minitab I have never worked, but I have used SPSS to carry out the principal component analysis. And without checking either Verimax or the other option, you cannot proceed.
Yeah,
So
that is what
I'm
my
not sure.
appreciation is.
Yeah, there are two things. You are saying iron value. Iron value is something that you have chosen between iron value and the minimum number of factors to be selected. That is the Scree curve. There are two things. One is iron value. So you take the Scree curve and or you decide the number of factors that you will extract. So, but without these, I'm not sure about how Minitab does this, but in SPSS, either way, I have seen the theory also in PCA. You have to pick one of the two here and one of the two there when you are extracting, you are finalizing the number of factors to be extracted. So I'm really unable to understand how are you saying that without, if not Verimax, then the other method might have been picked up. I mean,
Sir,
that's my submission.
yes, sir. Sir, just I use the mini tab to calculate the eigenvalues. Once the eigenvalues
Okay.
were calculated, then the formula were used in Excel, and I got the
Okay.
results, sir. Yes, sir.
No, but
Total
say,
calculation will not be carried out by using mini tab. Only the calculation
okay.
of the eigenvalues were done.
You tell me what were the inputs? I'm sorry
Input,
because I missed that. What were the inputs?
sir, inputs are the
Okay.
peak current, then gap voltage, then pulse
Okay.
on time, then
Hmm.
flushing pressure.
Okay.
Yes, sir. And output was objective was a higher MRR, lower tool
Okay.
wear rate, lower
Uh-huh.
overcut, and lower taper.
Okay. I
Yes, sir.
think then it needs to be discussed at length. Why? Because for
Yes, sir.
this particular situation, you are not supposed to use PCA, according to my understanding on PCA. The PCA is a technique that can be used normally for the responses which are collected through using the Likert scale. And when I say Likert scale means it's a technique where you are not going to have a crisp value.
Okay, sir.
You are going to have say normally those studies where you are having some fuzzy scales are there, and those fuzzy scales you are getting say at a scale of 1 to 5. Just check because I mean I may not be correct because I have not gone into the totality of your problem, but superficially I do understand because I did made use of this technique in one of my PhD student. So there's something to be checked. Particularly, are you using correctly PCA or not?
No,
I
sir.
doubt it.
Currently, I'm not using. I used 4 5 years back, and
Okay,
a
fine.
paper was also
Okay,
published.
okay,
Paper was published in the Journal of Material Technology Research (JMTR).
okay, okay.
So yes, sir.
I think
And
I
sir,
think the for the inputs and outputs you are handling,
yes, sir.
Minitab and people normally go for regressions. People normally go for ANOVA
Yes,
and
sir.
many other coupled because I am not having much exposure into that. But
Okay,
because
sir.
I had been guiding some of the doctoral work and PG work, wherein statistical data is available on a Likert scale.
Yes, sir.
So their PCA is extremely relevant.
But since I saw one paper in which the machining problem was also solved by using PCA method.
Maybe. I
Yes,
think
so
then
that's why I
we have to
use
look
that.
into it. No problem.
Yes,
That we can
yes.
see in totality sometime.
Okay,
So
sir.
I think with this, we can thank Dr. Milind Sharma ji for excellent talk with the group. And of course, Dr. PM Mishra is sitting there and waiting for his chance to share word of thanks. Thank you, Milind ji. We'll keep talking in future also. Thank you very much.
My pleasure. My pleasure.
Milind sir, thanks a lot on behalf of the whole mechanical engineering department. And once again, I apologize for the delay in the
No problem. No, nothing. I mean, now you are embarrassing me.
from shifting from one platform to another. And we will be hoping a future association with you.
Definitely. My pleasure. My pleasure. Thank you.
Thank you, sir.
Thank you very much. Okay, namaskar.